not even in primary, but even in mathematics when you do, for an example, the square root of a negative. Let me just put a negative 1. So if you can punch a square root of a negative 1 in your calculator, it says error. So normally they used to say a square root of a negative doesn't exist, which is true, it doesn't exist, but we can express complex numbers, a non-real number in a complex form, especially a square root, a negative number inside a square root. So we say it's a non-real number. So normally we'll use a symbol which is J. So when you see a J, and most of some problems just know it represents square root of negative 1. Sometimes in electrical or even in maths, we will see I. We will see I. So it's either J or you'll see I. It represents the square root of a negative 1. It represents the square root of negative 1. So it's something that I wanted to recall because I know most of you might have done maths long time ago. But if you did social algebra and you still only did algebra, please even recall what we call recall set rules. Please recall set rules. So these are very applicable when we deal with sets. They go hand in hand with exponential laws. So you must even know exponential laws. So but let's start with the set rules, right? So there's this rule that you must recall that if you have a square root a multiplied by square root of a, the answer is equals to a. So normally I interpret it in this way: if the roots are the same and what is inside the roots are the same, you just take one of the factor inside the root. So you can use your calculator and say root 2 times root 2. It will give you an answer which is 2. It's like you're multiplying bases which are the same of 2 to the power of half times 2 to the power of half. Or here, let's say it's a to the power of half times a to the power of half. When the bases are the same, you add the exponents. That's why you have a to the power of 1. So even in this case, for example, if now you have, let's say, a times root b. So the roots now, the roots are the same, but the factors inside the roots are not the same. Now we are going to take one root and multiply the factors which are inside the roots. So we're taking one root because we have a square root. We'll say a times b. So a times b, that is the root. And again, you need to know from this side to the other side. If you have multiplication inside the square root, I hope it's clear. Only when you have multiplication, you can have a square root of a multiplying square root of b. From here, you can move to this side. So that is the rule of sets. Okay, let me not add the other one, but for your information, I'm just going to add it, but we're not interested into it. If let's say you have root of a, let me put n here. It can be 2 or 12 or 20. Multiply by root. Let me put root. What? Let me say root x. Let me put m here. But just this is a bonus that you need to recall. So the rule states that if the roots are not the same, the factors inside the roots are not the same. Therefore, you need to multiply the roots now, the root number. So you multiply n times m. So I'm going to say n times m. N times m. It's not clear. Therefore, what you're going to do now is the root, not the root, the factor inside the n root is going to be multiplied by the exponent of the mth root. So you're going to say m a to the power of m. So it's 1, exponent is multiplied by m. Same thing, the other factor in the other root going to be multiplied by the number of let's say the value of the root of the opposite root. So we're going to say x to the power of n. So that is the rule that if you've forgotten it, recall, but we don't need it, but I'm just saying recall that. It's math. So that's a bonus rule. So where are we going with this recalling, recall the rules? So this is where we're going. For an example, if let's say you have to simplify, um, let's look into this. Let's say square root of negative 20. Square root of negative 20. So you need to try and express it in either in a non-real form or a non-real number. Because we know that square root of negative 20 is equals to, it says undefined error. So this is what we're going to do. So please, you need to recall even perfect squares when it comes to this. Perfect squares. Perfect squares are some value, let's say numbers or values that when you put under a square root, they come out as a whole number, not in decimals and so forth. So I'm recalling perfect square. So you need to recall perfect squares. I hope you know that 2 to the power of 2 is equals to 4. Or even 1 to the power of 2 is equals to 1. 3 to the power of 2 is equals to 9. And 4 to the power of 2 is 16. So which means if you put 16 under a square root, you're going to get 4. If you put 9 under a square root, you're going to get 3. So we call these perfect squares because the square root gets rid of the square and gives you the whole number. I hope it's clear. So we need to try when sometimes you're simplifying these values, start using perfect squares. For example, with 20, I know that if I can split having factors of 20 consisting of 1, which is a perfect square. If you want, you can do that. So first of all, I can split having, let's start with, which one can I use? Maybe I can say, please always have negative 1. The other one, in fact, let's start with 20 before I go there. Start maybe by splitting by having 20. Because you want to get rid of the negative 1. So make sure you have negative 1 and the other factor, which is 20. We know that square root of negative 1 is j, isn't it? Therefore, you'll have square root of what? Of 20. I hope it's clear. So we use this rule here. We have factors multiplying each other. I split the square root of negative 1 times square root of 20. So that's what we did. Square root of negative 1, it is j. Square root of 20, even without wasting time. We're supposed to have j. We know that square root of 20, it must be 2 root 5. So we know that square root of 4 is 2. And then 5 doesn't have a root because factors of 20 is 4 times 5. But you can use your calculator, square root of 20, it is 2 root 5. Square root of 20 is 2 root 5. So obviously, where does it come from? So we make sure we have to get rid of the negative 1 and now find the root of 20. So when they say simplify, this is what they mean. So make sure we express the number in complex form. We know it's undefined, so please express it in complex form. So square root of 20 is, it is 2 square root 5. Say some plus, yeah. No, not plus. Yeah, thank you for saying that. So normally sometimes you can see your complex number expressed in this way. Can be j, the coefficient, or you can see it as in this way, as 2 root 5. So 2 root 5 j. Can express in that way. Remember, factors you can rewrite anyhow. It doesn't matter the order. When you say root 4 times or root 5 times j, it still gives you negative root 20 when you multiply. I hope it's clear. So sometimes can be expressed in this way or in that way. Just arrange let's say the real values being the coefficient of j. I want to put maybe last one minute of time. Maybe the okay, let me introduce this part because I want to combine it with it. Yeah, let me introduce this part. So I'm just giving you soft things here. Please recall exponential laws. Please recall exponential. Yeah. If I multiply, the bases are the same, we add the exponent. If we divide, the bases are the same, we subtract. If let's say the exponent is negative, we want to make it positive, we drop down the base, the exponent changes. If let's say we have multiplication inside the bracket, but we have a power, everything inside the bracket carries the exponent outside, or the exponents are multiplied by the outer exponent. So please recall that. But I'll draw in the very critical ones that we want. If let's say we have a to the power of n, let me start with this one, times, yeah, let's say n times m. The exponent is n times m. The exponential law states that you can factor out one exponent. We factor out one exponent n. We can factor out one exponent. If we have multiplication, we can factor out one exponent. So we factored out the exponent there, which is m. If the law this allows you can multiply m times n, then you'll have mn in the exponent. That I used to call this bracket law of exponent. I used to call it that bracket law of exponent. So if you started in N3, you'll remember it price, because it could be last block. In N3, remember they do loss of exponent. So if you expect you to know it from metric and technical notes. Okay. So the other law, if let's say we have n plus n. So now we have addition in the exponent. In the index, we have addition. So the rule says that if you have addition, you can have a multiplication of, it means that it came from multiplication of similar bases. They can put it that way. So of a to the power of n times a to the power of n. So if the bases are the same, we add the exponents. So that is the rule. So if you see addition, just know that, oh, I can have multiplication of similar bases, different powers. So